Okay, so Abhishek, so now I'm going to start your technical snap for engineering services exam interview, and you opt
Yes,
strength
sir.
of material, correct?
Yes, sir. Okay, sir.
Okay, Abhishek, so
Yes, sir.
define how you define strength of material subject.
The strength of materials subject is a subject which deals with the deformation of a body within the elastic limit.
Okay, and okay, so how you define stress?
The stress, stress is the internal resisting force against a deformation. When a
Internal resistance
body
force per unit area.
is a per unit area against a deformation when a body is subjected to some external force.
Okay, so can you draw stress versus strain curve for ductile material?
Yes, sir. So for mild steel,
Yes.
sir,
Okay, so can you define each and every point of this curve?
yes, sir. Sir, A
Hmm.
is the proportional limit, B is the elastic limit point, and C is the
Hmm.
upper limit point, D is the lower limit point, and E is the plastic collective point, and F is the ultimate strength, G is the fracture strength.
Okay. So what do you mean by plastic plateau?
Sir, it is the reason in the stress strain diagram where we applied a load. Uh, mm, is a reason where strain is observed without increase in load.
Is it possible in mild steel?
Yes, sir, it is possible in mind still uh, due to the Kotel effect. No, sir, this is not the Kotel effect. So due to the molecular arrangement of the particles in steel.
Okay. And how you draw stress strain curve for concrete mixture for compression load? This is for tension. I'm asking for compression.
Sorry, sir, not getting. Uh,
Okay.
yes, sir.
Hmm. So how you define toughness?
Set up sir, and toughness is the property of the material by virtue of which it absorbs the energy up to the fracture points in a load deflection up to the fracture points. It can also be the area up to the fracture points in load deflection curve. Like
Hmm.
toughness during a car accident, the how much the car will deform, it is because of the how mm, how much the car deforms. It depends on the energy absorbed, which is related to the toughness.
Hmm. Okay. And what about modulus of rigidity?
So modulus of rigidity is the energy stored up to the fracture per unit volume, and the area bit in the diagram of stress strain curve gives the modulus of rigidity up to the fracture.
Area gives us modulus of rigidity.
Yes, sir. Stress strain curve up to fracture.
Okay. And what is strain energy?
So it is the energy stored in a body due to its deformation.
Hmm. And resilience?
Yes, sir. Sir, it is the energy stored up to the within the elastic limit in
Mm.
a body, and it can be defined as the area of the stress strain, the load deflection curve up to the elastic limit.
Mm. Area under resistance diagram under elastic limit. Area
Sir,
under the stress, area of stress strain diagram under elastic limit.
sir, resilience is low and area under the load deflection diagram up to the
And
elastic.
if I write area under the stress strain diagram, then what it signifies?
Sir, it signifies the material property that is modulus of resilience.
Modulus of resilience.
Sir,
Okay, and what do you mean by flexural rigidity?
sir, flex, sir, it is the yes, sir, sir, it is the resistance offered by the body due to in bending. Mm,
Resistance offered by the body in bending. For what
mm,
resistance?
sir,
Resistance against what?
due to action of a load on bending.
Against the rigidity, against a deflection.
Yes, sir. Again, sir.
And what do you mean by section modulus?
Sir, section modulus is a parameter which is used to which is used. सर ये एक पैरामीटर होता है जिसके थ्रू हम बता सकते हैं कि बॉडी कितना मूवमेंट बियर कर सकती है और
Let us suppose if you want to design a beam under rigidity criteria, then how you proceed?
ये sir, the beam which have a more modulus suction will offer more resistance to the bending.
Hmm. And suppose if you want to design under dynamic condition, then
Sir, in that we have to go for um, endurance limit, I think.
and what is the purpose of deflection of beam? Why we study this chapter?
Sir, because to find the purpose to find the deflection as per the serviceability criteria.
Hmm.
Otherwise, it will give a psychological. It will have a psychological impact, or and if the load deflect, if the beam deflect beyond its permissible limit, it may induce a crack in the beam,
Hmm.
and that's sir अभी तो यही सोच रहा हूँ।
Any other objective?
सर अभी तो यही सोच रहा
Okay. And how you define column?
हूँ। The column is a vertical member which transfer which takes the compressive load and transfer that load to the foundation from superstructure to the foundation.
Hmm. Transverse load,
Yes, sir. Yes, compressive load.
axial compressive load.
HCL. Yes,
And what do you mean by slenderness ratio?
sir. Sir, it is the ratio which tells the uh, how much a column will bend. Oh, sorry, sir. Um, it is the ratio. It is the ratio of the effective length to its the lateral dimension of in a column, and it will tell us how much whether a column will buckle or not.
Hmm. Means for safe design of column, the
Yes,
slenderness
sir.
ratio should be high or low.
So it must be low or as per the criteria given in code.
Hmm. It must be low. And what do you mean by axial rigidity?
Sir, axial rigidity is the Sir, axial rigidity is the load per unit deflection in a unit length.
Hmm. Okay, can you draw one shear force and bending moment diagram when you
Yes,
have a simply supported beam subjected to a constant moment at mid-span? Shear force and bending moment diagram
yes.
when it is subjected to constant movement at mid-span.
Sir.
Shear force diagram, I think it is wrong. Can you check it?
Yes, sir. Yes. Sir, SFD is constant throughout the length.
Okay, and how much reaction induced?
Sir, M by L.
MYL. Okay.
Yes, sir.
Okay, so one last question. Suppose you have a hydrostatic state of stress condition.
Yes, sir.
So for this, which theory of failure is applicable?
Hydrostatic force of compression. Yes, sir.
Hydrostatic state of stress condition.
Sir, distortion theory can be
Distortion
one
theory.
basis.
Okay. Okay. So according to distortion theory, can you tell me what is the value of yield stress?
Say equals to 0.576 Fy.
Mhm. You write equation and determine. First, you write equation for three-dimensional state of stress.
ये हाइड्रोस्टैटिक लोडिंग के लिए निकालना है.
Yes. Do you know what is hydrostatic state of stress?
Yes, sir. Sir, compression from all side
Mm-hmm.
when a body is in water.
Mm.
Sorry, sir, I got stuck in this.
Okay, so Abhishek, now I'm going to give your feedback, correct?
Yes, sir.
So अभी थोड़ा सा प्रिपरेशन की जरूरत है आपको, ठीक है ना? बेसिक्स अभी एक बार स्टडी करो.
Yes,
न्यूमेरिकल
sir.
पोर्शन आपका राइट है. जब मैं न्यूमेरिकल बेस्ड क्वेश्चन पूछता हूँ देन यू यू एबल टू गिव द आंसर, करेक्ट? जो
Yes,
लेकिन
sir.
जब थोड़े से कॉन्सेप्चुअल या कुछ थ्योरेटिकल क्वेश्चन पूछे जाते हैं तो वहाँ पे आप स्टक होते हो, है ना?
Yes, sir.
वहाँ पे हेजिटेट होते हो उसको डिफाइन करने में. सो एक बार उसको स्टडी करो फिर से अगेन,
Yes, sir.
ठीक है?
Yes, sir.
एंड एक बार प्रिपरेशन कर लो, फिर से डिस्कस करते हैं, ठीक है?
Okay, sir.
And you take 2 to 3 days time. And we also have one marathon session on YourPedia educational YouTube channel recorded
Yes,
by
sir.
Vijendra sir, correct? So you just watch. That one is definitely help you a lot, correct?
Okay, sir.
Okay, so all the best.
Okay, sir.